Hey, there's a little space on page 131 in your workbook that says notes. It's right up under the properties of radicals, and that's where we're going to take notes on this today. So we're trying to learn how to do two different things, adding and subtracting go together, and then multiplying on its own. All right, so first thing is before we add sometimes and after we multiply, we have to be able to break down all different types of radicals. So I'm going to go through a method with you that will always work no matter if it's a square root, a cube root, a fourth root, or a fifth root. Okay, so the way this works is if this number here is a 2, which we know is understood to be, I'm just going to start breaking down the factors of 32, and then I'm going to circle pairs of them. So I could start with, let's say, 16 and 2. Then I'm going to break down 16 into 4 and 4. Then I'm going to break down 4 into 2 and 2, 2 and 2. So what I'm looking at for factors are this 2 and then all of these 2's. And I'm going to pull out pairs because I'm taking a square root. I'm going to pull out pairs of them. So here's one pair that comes out as a 2. Here's another pair that comes out as a 2. So 2 times 2 is 4, and then my leftovers go under the square root. So the breakdown of the square root of 32 is 4 square root of 2. All right, so similarly, that's going to work the same with a cube root. I'm just going to start breaking down 54. So I'm going to use maybe like 18 and 3. The factors of 18 are 9 and 2. And I'm going to keep going. So this will be 3 and 3. So again, the factors I'm looking at is this 3, this 2, this 3, and this 3. And I want to pull out this time groups of 3. So I'm going to take this 3, and this 3, and I'm going to pull them out as 1, 3. So since it's a match of 3's, I'm going to take it out as 1 that goes on the outside, and then my leftover is going to go under the cube root. So that would be the cube root of 2. Okay, so again, that's going to work for fourth root. So I'm just going to start breaking down 80. So I might use 20 times 4. And then I'll break this into 4 times 5. And then I'll break this into 2. I can't do anything with the 5, and then 2 and 2. So what I'm looking for is groups of 4 of the same number. So that would be these 2's. There are 4 of them total. So since I found that grouping, I'm going to pull out a 2, and then I'm left with the 5. So that's the fourth root of 5. Okay, so hopefully by now you're getting it. If you're confused because I'm doing it quick, then you need to back up and watch it without writing. That would be helpful for you. Okay, so the last one we're going to do is a fifth root. And so what am I looking for? Groups of what? Hopefully you said 5. So we're going to take 729 and just start breaking it down. So I put in, and I just used in my calculator, I did 243 and 3. And let me just divide by 3 again. So this would be 81 and 3. Now I can do this. This would be 9 times 9, 3, 3, 3, and 3. Now remember, I'm looking for groups of 5 of the same number. So I have 1, 2, 3, 4, 5. So there's my 5. I can pull that out as a 3, and I'm left over with this fifth root, and that 3 goes on the inside. So this is the breakdown for that fifth root. Okay, so each of these is simplified version. And now that we know how to simplify, we can start adding and subtracting. So adding and subtracting is the same everywhere. You have to have something. So I hope that you're sitting at home thinking like terms. You always have to have a like something. It's kind of a pain in the butt to add and subtract in math. So in this case, we're looking for like terms. What do I mean by like terms? I mean, see where this sit, and this is, we'll call this J, E, F, of course. So this is our square root of 7's, are like terms. So what we're going to do is add the 4 and the 8, and then keep the like term of 7. Okay, now in E, that would be wonderful to do, except we don't have like terms in this case. We have a square root of 7 and a square root of 63. So what we've got to do is break this square root of 63 down until we hope that it makes a 7. So let's see. We're going to start with 9 and 7, and then this will be 3 and 3. Since I want a square root, this will be a 3 times the square root of 7. So what I've found so far is the breakdown of the square root of 63. Now I want to remember though that there was an 8 in the front. So all that means is that I'm going to multiply this thing by 8. And 8 times 3 is 24. So my new version of this question will be negative 2 times the square root of 7. I didn't do anything to that. Then I have minus, and instead of this thing, I have made it now 24 times the square root of 7. And now I have like terms. And negative 2 and negative 24 is negative 26 times the square root of 7. So that would be my final answer. And so for the last one, we're going to take the cube roots and break those down, and we hope that they end up with like terms. So we're going to start by doing 4 times 4. This will be 2, 2, 2, and 2. I'm going to take a group of 2's out. Remember, I want 3 of them. So that'll be a 2 times the cube root of 2. I'm going to do the same thing for this cube root of 54. So I'm going to use 9 and 6. This will be 3 and 3. This will be 3 and 2. So I have a group of 3's. I have 3 of them. So that would be 3 times the cube root of 2. And then luckily, my question had a plus sign. And then luckily now I have common denominators. So I can add 2 plus 3, which is 5, and then leave the like term. I'm sorry, I say common denominators. I meant like terms. So the like terms of cube root of 2 is going to stay the same. Okay, and then the last thing that we're going to learn how to do is to multiply. So the way that it works with radicals is you multiply the outsides with the outsides and the insides with the insides. Once you get your answer, you can simplify whatever's left. All right, so in this example, we have our outsides are negative 3 times 2, so that's negative 6. And then our insides, so we're looking at this part and this part, is going to stay the cube root of 5 times 4, which is 20. Now you want to think about if I broke this down, would I have a cube root? And I'm thinking about it going 5 times 4. I wouldn't get any sets of 3. So this should be my final answer. Okay, so that's an easy example. And then this next one over here, what we're going to think to do is to distribute. So we're going to have to multiply both of these. So I'm going to take this times this first, which means I want 3 times negative 4, which is negative 12. Square root of 2 times square root of 3 is square root of 6. And then my last one will be this one. So that will be 3 times 1, which is 3. And then square root of 2 times square root of 5, which is square root of 10. Now, if anything could be reduced in here, I would, but I can't break down square root of 6. I can't break down square root of 10. Therefore, my answer stays the same. Now, again, I went through quickly, so please feel free to back up and watch anything again that you'll need to, so tomorrow you can come in and practice right away. Good luck.